polygons. Yesterday we talked about dilation, right? And what's dilation? Enlarging or reducing something, correct? And so we talked about one thing that was consistent when a dilation occurred, which was what? The angle measure stayed the same, right? But then what happened with the size? They were proportionally bigger or smaller, right? Okay, so that's what we talked about yesterday. And then we also talked about the scale factor in the reduction or the enlargement. And what was true about the scale factor in enlargement? It was greater than 1, and in a reduction it is between 0 and 1. Okay, so today we're going to talk about similar polygons, which is kind of like a dilation. You don't always know if it's reduction or enlargement. You're really just looking to see that the two shapes are similar. And a similarity transformation is made up of a composition of one or more rigid motions and a dilation. So, like if I start with PQRS, if you look, you can see that it's reflected over line M, and then it's translated. Then it's reduced. It's dilated as a reduction. Okay? And so you could then say that this original pre-image, PQRS, is similar to this smaller one, okay? And it is a composition of a reflection, a translation, and then a dilation, okay? The symbol that we use to state that two things are similar is this little squiggle right here, okay? So congruence has a squiggle with an equals, but similar is just a squiggle, okay? And so a definition for similar polygons would be polygons having corresponding angles congruent and the length of the corresponding side proportional. Okay, so as you can see, there's a symbol that we use. We can look over here at these two shapes, and we can see that our corresponding angles are congruent. We have the 1 dash, 2 dash, 3, 4 dash. And then if we look at all of the corresponding sides, we could say, okay, well, 10 is to 5, as 8 is to 4, as 3 is to 6, as 6 is to 3, 6 is to 3, as 5 is to 2.5. And all of those are equal to what? They're all equal to 2, okay? So they all reduce to be the same amount. So we know that the sides are proportional, and we can see that the angles are congruent. When you state two polygons similar, it's a lot like when you state them congruent. The order in which you state it is important. Like the A corresponds with the E, and that tells me that those are the two angles that are congruent to each other. And the B corresponds with the F, those are congruent. The C with the G, and the D with the H. Okay? So just from this similarity statement, I can determine which angles are congruent. I can also determine which sides are proportional. Okay? Because I know that AB corresponds with EF, so that can be written as a ratio. And BC corresponds with FG, same thing, it can be written as a ratio. And CD with GH, and AD with EH, okay? And so you can write all of those as ratios, and they're all proportional to each other. They should reduce to be the same thing. So, if we were asked to determine whether each pair of figures is similar, and so write a similarity statement, if not, explain why. Well, the first thing I always do is look at the angles, because if you can show that the angles are not the same, you don't even have to mess with the sides. So we see that we have a pair of right angles, right? This angle is 30, which means angle B is going to have to be what? 60 degrees. And then angle E is 60, and F is 90, so D is going to have to be 30. Okay? Now what I want to do is I want to compare the sides. And so I need to look at what they're across from. So, like the 12 and the 9 are across from the right angle. Those are the hypotenuse, so they're going to correspond. So I could write 12 is to 9, and then 6 is going to correspond with what on the other triangle? It's going to correspond with 4.5, so 6 over 4.5, and then 6 radical 3 over 4.5 radical 3. Now I can easily tell that these last two are the same, because I can cancel out those radical 3s, and that's the same fraction, right? But I don't know whether or not it's similar to 12 ninths. So you could do one of two things. You could take this one and cross multiply, or you could reduce both of them. Okay? If I reduce this one, what goes into both of those? 3, so it ends up being 4/3. And I can change this to 60 over 45, and that reduces to what? 4/3. And the same thing with this one. I could divide it out in my calculator. If I divided it out, I would have gotten 1.3 repeating on each one of them. Okay? You know that when I put the 0 there and I move the decimal over, I multiplied the top and the bottom by 10. That got rid of the decimal. Okay. That's where I got 60 over 4. Alright, so what can I say about the sides? They're proportional. The angles are congruent. So are they similar? Yes. So when I wrote my similarity statement, if I did triangle ABC, I'd use the similar sign. It's similar to triangle. How would I state the other side? DEF. Okay, so there's my similarity statement. Now let's look at this one. I look at all the angles and they're all what? 90. So I know that corresponding angles are congruent. Now I need to look to see if the corresponding sides are congruent. And inevitably people mess this up. They think, okay, well there's just a different one here and a different one here. So that tells me they're proportional. No, I need to compare. I need to take big to big, little to little. And I can just look at those two fractions. They're not the same, are they? No, even if I cross multiply 35, 36, those aren't the same. Okay? So the answer is the polygons are not similar. The sides are not proportional. Okay, everybody get that? Sorry. Alright. Now we talked about scale factor yesterday. Okay? And when we talked about it yesterday, we always said that you put image over pre-image. No, this is not really a dilation, they're just similar figures. So sometimes they specify how they want the scale factor, and sometimes the choice is up to you. Okay? So, like, oh, yeah, when it says it's simplified, they want you to give it as a fraction reduced. Yes. If you give it to them as a decimal, it'll count it wrong. Yeah, you're right. Oh, really? Oh, man. Okay, so in this one, they want A, B, C, D to E, F, G, H. These figures obviously are similar. I think that's kind of a given here. Corresponding angles are congruent. I can pick any pair of corresponding sides, and that should give you the scale factor. I do need to give it how they ask for it in this order. So which two sides do you want to go with? A, D, and E, H, okay? So then I would do 16 is to 4, because this is from A, B, C, D, this is from E, F, G, H, and they wanted in that order, and so that reduces to what? 4, okay? But what if they wanted in the reverse order? What do I do? It'd be 1 over 4, right? So it'd be 4 over 16, which reduces to 1 over 4. Just be careful and get it the way they ask. If it doesn't specify, then I usually go left to right. You know, you can do it however you want to. Yes. Well, in this case, yes, because in this scale factor, they're wanting big to little. Here they want little to big, and you're comparing the same size. So yeah, they would just flip. Yeah. But in a problem, I wouldn't ask for both. I would just ask for one or the other. You just need to make sure you set it up right. Does that make sense? Okay. All right. Okay, so ABCD is similar to RSTUD. We want to find X and Y. Okay, so they're similar. We know that the sides are proportional. So if we want to figure out what X and Y are, I need a pair of sides that correspond that I know for sure. B, C, and ST, right? So I could use that, and I can set up a proportion. So I could do 4 is to 18, and if I wanted to find x, how would I set that up? No. Look, guys, if 4 is to 18, that's little to big, I have to go little to big, which is 3 to x. Okay, so then I cross multiply, and I get 4x equals 54. Divide both sides by 4, and here's what the answer is. Huh? 17? About 13.5. 54 divided by 4, I get 13. Okay. Now, what if I want to do y? Am I going to do anything different? I'm going to use that same side that corresponds. 4 is to 18 as 5 is to y plus 2. So I'm going to cross multiply, which I'm going to have to distribute here. 4y plus 8 equals 18 times 5, 90. Subtract. Subtract 8 from both sides, and that's what, 82. Divide both sides by 4. Where'd you get 20.5? And so y is 20.5. Okay, now let me ask you this question. Instead of using 4/18, could I have reduced that to 2/9? I could have, as long as you stay, vertical. Don't go across the equal sign. Okay. You could reduce that, make your numbers just a little bit small. You don't have to, but you can. Okay. Now, this next one is said, find the scale factor RSTUV in ABCDE. What's that going to look like? 18 over 4. And then I need to reduce that, so it's going to be 9 to 2. So my scale factor would be 9 to 2 if they ask for it in that order. Okay. All right. Here's another one. Triangle ABC is similar to triangle XYZ with a scale factor of 2 to 3. If the lengths of the sides of triangle ABC are 6, 8, and 10 inches, what are the lengths of the sides of XYZ? So we've got ABC and XYZ. And the sides are 6, 8, and 10. Okay, and I'm going to let this be little z, this be little y, and this be little x. Okay? Alright, and it says that the scale factor is 2 to 3. Okay, so what would I do to figure out, let's say, x? Let's set up remember the sides are proportional, okay? So the sides are proportional, so we're going to set up a proportion. So what are you going to do? To find x, you're going to put 6 to z. I asked to find x, so what would that be? 8 is to x, right? You were right, you were just using the wrong variable. Yeah. So 8 is to x as 2 is to 3. And so then, let's say, to find z, what would you do? 6 is to z as 2 is to 3. And then to find y, what would you do? 6 is to y as 2 is to 3. Make sure that you set it up the right way. Somebody said y is 10. If I had done y over 10, what would I have done over here? 3 over 2. Okay? Alright, so we cross multiply and we end up with 24 equals 2x. And so x is 12. Here we get 18 equals 2z. And so z is 9. And here we get 30 equals 2y. And so y is 15. Okay, last thing, perimeter of similar polygons. If two polygons are similar, then their perimeters are proportional to the scale factor between them. So if I know that two figures are similar, I know that their sides are proportional. I also know that their perimeters are proportional to a pair of corresponding sides or to the scale factor. Okay? So, I know that the perimeter of this is to the perimeter of that as one corresponding side is to the other, or the scale factor. Okay? So, in ABCDE is similar to PQRST, find the scale factor. of A, B, C, D, E, to P, Q, R, S, T, and the perimeter of each polygon. Okay, so I'm going to look at this one first, and I have some congruency. I know that this is A, so that means that BC is A. And A, E, and CE are equal, so they are both 4. And I come over here, and I see that R, S, and PT are both 3, and I don't know what the other ones are. Okay? Now, it asked me to find the scale factor. What's the scale factor? A, B, C, D, E to P, Q, R, S, T. 4 over 3. Okay, because it says A, B, C, D, E to P, Q, R, S, T, so that's big to little, right? What is the perimeter of this? It says A, B, C, D, E to P, Q, R, S, T. It's asking for the scale factor in that order. Okay, does that make sense? Okay, I'm away from the dilation. Okay. All right. So the perimeter of this guy is 30. I don't know what the perimeter of this one is, but I know that their perimeters are proportional to the scale factor. Okay. So if I know the scale factor is 43, what can I do to find the perimeter? Okay. And I heard both. I heard 30 over x and x over 30. If it's 4 to 3, it has to be 30 to x. If it's big to little, it's got to be big to little. Don't flip them. Okay, that's important. All right, so we cross multiply, and we get 4x equals 90. And we divide both sides by 4, 22.5. And so x ends up being 22.5. Now, could you have gone and found each one of these sides and then added them all together? You could have. That's a lot of work, isn't it? And if you don't remember that the perimeters are proportional, that's definitely what I would do. But if you could try to remember that, it shortens your work by like 3 equations. 3 equations. Okay. Okay. Uh-huh.
So does it not necessarily matter
Now, which one you make X, Y, and Z? No, I just tried to keep it with the corresponding angle across from it. So like this is big X, this is little x. Like this is big angle X, this is the length of X. You can do it however you want to, I don't care. Because it just asks for all 3 sides. Yeah, so that doesn't matter. Okay. All right, any questions? Okay.